do number 10 from 8.1?
Yeah. Yeah, so 8.1 was just a bunch of different integrals with all kinds of different techniques. So when we come across an integral, here we have the integral 72 dx over 1 minus cosine 9x. You kind of just need to think about all the different techniques that we had written down from section 1 and just kind of try them. For this one, it's looking like because I have that 1 minus cosine 9x there in the denominator, this is going to be a conjugate question. Anytime you have 1 plus or minus cosine or sine cosine plus or minus 1, try multiplying by the conjugate to see if that helps. So I'm going to take that 72 over 1 minus cosine 9x and multiply that top and bottom by 1 plus cosine 9x. Okay, so that's all a conjugate is you just change the sign in the middle of a binomial like that. So now I'm multiplying everything out. This is still an integral. The top, there's not really much I can do. It's still 72 times 1 plus cosine 9x. I guess we could have distributed the 72, but I would probably just pull that out of the integral before distributing. In the denominator, though, when we multiply 1 minus cosine by 1 plus cosine, foiling those together is going to cancel out pretty nicely. So we're going to have the 1 times 1, which is just 1. The inner is negative cosine 9x. The outer is positive cosine 9x. And then the last is going to be negative cosine squared of 9x. Okay. All right, so again, like I said, I would pull that 72 out, leave the numerator alone. The denominator is now something that should be, it's pretty common and it's going to show up a lot for us. 1 minus cosine squared is the Pythagorean identity. That would just change into sine squared of 9x. Still have my dx out here. Okay, so here, still not quite done, still quite a bit to go. 1 plus cosine 9x over sine squared 9x. The trick here is we're going to split that fraction into two separate fractions. So we still have the 72 out in front. We're going to have 1 over sine squared. 1 over sine squared simplifies down to be cosecant squared. Plus, then we're going to have cosine 9x over sine squared 9x. And I'm going to break that up. So just to add an extra step to show you what's going on, I'm going to write this as cosine 9x over sine 9x. And then we still have another 1 over sine 9x to be that sine squared. The reason we do that is that now again we could use the reciprocal and quotient properties. Cosine 9x over sine 9x is cotangent 9x. 1 over sine is cosecant of 9x. Oh, these are supposed to be 9x's and the cosecant out front here too. Sorry about that. Okay, it still looks awful, but these are now things that we can find the antiderivative of. So I know it's probably been a while since you guys have done trig derivatives and antiderivatives, but it's something that's going to show up a lot for us. So I think all of these are on that integration table. So if you're ever unsure, just check back to the integration table. The antiderivative of cosecant squared 9x. First thing we need to worry about is the 9 on the inside. That's going to come out as a 1/9. Then the antiderivative of cosecant squared is negative cotangent. All right, so that's the antiderivative of cosecant squared. Then we need to do the antiderivative of the cotangent 9x cosecant 9x. Again, a 1/9 is going to come out. That is the antiderivative, or that has antiderivative cosecant. All right, so I know my handwriting's pretty awful. It's really hard to write when I have my laptop like open instead of in my little tablet mode. I'm copying the same thing but trying to write it a little bit neater. Oh, I don't need the dx on the end. Last thing you could do would be to distribute the 72 into there. 72 divided by 9, I think, is 8. And we get that. Plus C. Don't forget your plus C. So just to write it in to make sure it's right. Negative 8 cotangent 9x minus 8 cosecant 9x plus C. I think the biggest mistake I always see people make is they forget to pull the 1/9 out whenever you do the antiderivative. It's kind of the opposite of a chain rule. So does that help? Does that one make sense? Is there any questions about that one?
No. That was good, thank you.
Cool. You're welcome. Anybody else? Any other homework questions? Sections 1, section 2? Okay. Great. So all I kind of want to do here is just to kind of, before we go, we won't stay the whole time if you guys don't have questions, is let's look a little bit more at this 8.2 stuff, just because we did so much 8.1 stuff before. I'm just going to kind of pick one here that I think looks neat, and then we'll do it. Oh man, some of these are hard. Okay, let's do this one. It's pretty difficult, but I think we can manage it. So we'll do this one together, see how we feel, and then we'll probably get out of here. Unless you guys have more questions. So this is number 8 on this homework. Integral 9x squared minus 4x all times e to the 2x dx. Okay. So, just looking through this, the key for this one is the fact that we have two functions multiplied together and we cannot do u substitutions. We'll try integration by parts. With integration by parts, you need to set up a u and a dv. You want to set up your u to be something that's easily differentiable, that breaks down. Set up your dv to be something that you can at least find the antiderivative for. So for this question, I'm just going to go ahead and let u be that entire thing up front, that 9x squared minus 4x. The dv, I'll let be the e to the 2x dx. Okay, once you set up your u and your dv, you're going to find your du and your v. Du would just be the differential of u, so taking the derivative of that, we get 18x minus 4, and then a line. Taking the antiderivative of dv, and be careful here, a 1/2 is going to come out, and then just leaving the exponential alone, e to the 2x. Cool. Then the formula for integration by parts is u times v minus integral v du. So we're going to multiply the u times the v together. I'll kind of multiply it all out. We're going to have the 1/2, then that 9x squared minus 4x, then the e to the 2x. So I was just kind of rearranging that multiplication so that it looks a little bit neater. That's going to be minus the integral of v du. So the v, 1/2, du, 18x minus 4. I still have that e to the 2x floating around, and now this is a dx. Okay, So we can simplify some of the stuff down. I'll go ahead and distribute the 1/2 out of everything. Okay, so this stuff out in front, we're just going to leave that alone. Nothing that we can do there. But now we have another integral that we need to solve. So the integral of 9x minus 2 e to the 2x dx. This is still not something that we can solve with any other method except for integration by parts, which means that we are going to have to do integration by parts again. So we're going to define a u and a dv. Again, I'm going to let my u be that polynomial, the 9x minus 2. The dv will be the e to the 2x dx. So then du is just going to be 9 dx, and v again is going to be 1/2 e to the 2x. All right, be very careful of plugging that back in. Oh no! Oh, sorry, I hit the wrong button. Hopefully it's still all there. It might just take a second to come back up. There we go. Okay, so picking up where we left off, we still have this term out in front, the 9/2 x squared minus 2x all times e to the 2x. That's going to be minus this integral, where this integral we're going to do another integral by parts. So it's going to be u times v. I'm going to write that as 1/2 times the 9x minus 2 e to the 2x. That minus the integral of v du. So v times du is 9 times 1/2, or just 9/2 e to the 2x dx. Closing the bracket. Okay, so I know I just did a lot there. So just to back and talk through it, we were here. I just copied down this first part. That came straight down. This integral, we did another integration by parts. So this, with the minus sign, stayed out front, but the integral itself I put into brackets with the u times v, and then minus the integral v du. Okay, simplifying stuff down. This stays. This minus sign is going to be distributed onto both of these terms. So this is really a negative 1/2 that's going to go onto everything here. So I'll write that as negative 9/2 x, and that's going to be plus 1 e to the 2x. For this integral, this 9/2 you can just pull out of the integral, and then the antiderivative of e to the 2x is a 1/2. So this minus sign out front cancels out with this minus sign, so this is a plus, and then it's going to be 9/4 e to the 2x plus c. All right, so I know that's kind of everywhere and kind of ugly looking. So what I'm going to do just to make it look a little bit nicer is every single one of those terms has an e to the 2x in it. I'm just going to factor that all the way into the front. Then I'm going to have the polynomial 9/2 x squared from here, negative 2x, negative 9/2 x plus 1, and then plus 9/4. All right, so that's just factoring e to the 2x out of all of that to make it so I can combine like terms a little bit easier. I do not have any other squared terms, so that 9/2 x squared just stays. Negative 2x minus 9/2 is negative 13/2, I think. 1 plus 9/4 is 13/4. And then you can just leave it kind of like that. There's no point simplifying this one down anymore. If you type it in like this, the homework should count it right. I know that was a lot. I don't know, it's kind of sloppy looking at it up here. I hope when you have like actually lines on your notebook and stuff that it looks a little bit nicer. But with these integration by parts, there's just a lot of steps to it. I don't think any of it is hard. I just think that it's messy, and if you have just one minus sign in the wrong spot, it messes up the whole problem. So be very, very careful. Make sure you're putting parentheses and brackets around stuff. That way you know what constants get distributed where. Is there any questions about this question, integration by parts? Are we all good with integration by parts?
I have a question.
Sure.
I keep forgetting, what is like the base formula for the integration by parts again?
It's this formula up top here, that uv minus integral v du.
Okay.
That's the formula. This thing here, uv minus integral v du. So the first thing that you do is you find your u and your dv. And then you differentiate the u to get the du, anti-differentiate the dv to get the v. Once you have the u, the v, and the du, you can plug it all into this equation.
Okay, alright. Alright, thanks.
You're welcome. Anybody else? Any other questions here from the section 2 stuff, integration by parts stuff? Last call, otherwise we'll end a little bit early again. Okay, cool. We'll end it here then. Yeah, it's going to take some work. I would highly recommend that you work ahead into sections 3, 4, and 5 over this weekend. That way you can ask questions during the Tuesday meeting at 6 or the next Thursday meeting. We're going to be finishing up chapter 8, not next week, but the week after that, and then testing on that. I think that's all I got for you. Other than that, just kind of, keep checking your emails. If you have any questions from the homeworks, send me an email and we can work through it together. Trying to think if there's anything else. I guess you're good. Okay, cool. So we'll end it here. Thanks for coming, and I will see everybody hopefully Tuesday, 6 p.m.